The table shows the temperature of a fish tank during an experiment. We're going to graph the data and then find the slope and the y-intercept from the graph. And then we're going to write the equation for the graph in slope-intercept form. There's a few ways that we can go about doing this. Our goal here is to get the graph on our quadrant here. We've just got the first quadrant because all of our values are positive. So we need to get the graph into the first quadrant. And then we need to find the slope and the y-intercept and write the equation in slope-intercept form. Now the problem says graph the data, then find the slope and y-intercept, then write the equation. But what I notice is that maybe doing it in that order is perhaps not necessary because the table that we're given tells us the y-intercept. Remember, the y-intercept is the spot where the input or the x value is 0. And right here at the top, the very first value we have has a time of 0 and a temperature of 82 degrees. That's the y-intercept. The y-intercept right there is going to be 82 degrees. So I'm just going to go ahead and mark that right off the bat, that this is the y-intercept, which means whenever I write my equation in slope-intercept form, my b value is going to be 82. We can also get the slope right off the bat too. What I notice is that the x values are all going up by 1. 0, 1, 2, 3, 4, 5. The x values are increasing by 1. And as the x values are going up by 1, what's happening to those y values? Well, the y values are going down. 82 to 80 to 78 to 76. The y values are decreasing. So as the x values go up by 1, the y values are decreasing. That tells me that the slope is going to be negative. As x increases, y decreases. What is y decreasing by? Well, it's decreasing by 2, from 82 to 80, from 80 to 78. So as x increases by 1, y decreases by 2. And that means my slope, which is the change in y over the change in x, slope is going to be negative 2 over 1, which of course reduces to negative 2. So in my equation, my slope is going to be, or my m is going to be negative 2. If I have the b and I have the m, I can go ahead and write the equation in slope-intercept form. It's going to be y equals negative 2x plus 82 because slope-intercept form is y equals mx plus b. So there it is. There's slope-intercept form. So although the problem says graph it and then go find the equation from the graph, we can actually find the equation from the table. It's easy to do from the table because the table gives us the y-intercept and then it's pretty easy to find the slope. Since the x's are changing by 1, it's pretty easy to find. Okay, so we've done that part. Now we need to actually go ahead and graph this equation. So as I said, it's all positive values here. So we only need the first quadrant. Let's go ahead and label our graph. We don't have really good labels on the x and y axis. Let's go ahead and do that. So our x-axis we decided is going to be our time in hours. And that means by default, our y-axis is going to be our temperature in degrees Fahrenheit. Okay, so what do we need to go by? Like, what should each line be worth on the graph? So our x's, or time, goes from 0 to 5. So we just need to make sure that along our x-axis, we can at least go to 5. Well, I can tell without counting that I've got way more than 5 lines on the x-axis. So let's just go ahead and if we start at 0 here, I'm just going to do every other line. So let's do 1, 2, 3, 4, and 5. And I've got a whole bunch of extra space on the end of that graph there. That's fine. Extra space is fine. I could have gone by 3s or maybe even 4s if I wanted to use the entire line, but it's fine. No need to. Now, The y-axis is going to be a little different. I need to go to at least 82 because my highest number is 82. So now I actually do need to count how many lines I have on the y-axis so that I know what I need to go by. So let's go ahead and count. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 lines right there. And I need to go up to at least 82. So that means I can't go by fours. If I went 4, 8, 12, 16, I would max out at 80. 4 times 20 is 80. So I can go by fives. Fives would work. I don't love the idea of going by fives though, because all of my numbers that I have here are multiples of 2. 82, 80, 78, 76. So going by fives, I don't really love. I like the idea better of going by an even number. So maybe instead of going by fives, we could go by, how about eights? I think eights is good. Let's go by eights. So we're going to go 8, 16, 24. Now, because I'm going by eights, I'm going to get above 82 as I go along, and that's okay. It's okay to have some extra space left at the top. If you want, you can use a calculator to make sure that you are correctly going by eights, or your graph may have a different number of lines than mine do. I'm just going to stop right there at 120. I don't need to go higher than that for going up to 82. 120 is excessive. Okay, so my y-intercept is at 0.82. I'm not going to put the point 0.82 on there though, because I would have to estimate where 0.82 is, but I don't have to estimate where 180 is. I can actually do 180 on my graph. 180. There's the point right there, 180. In order to graph a line, I only need 2 points, so I just need one other point here, and 72 is the one that I'm going to use, 572, because I've actually got 72 on my y-axis. So let's do 572, which is right here. There we go, 572. And again, the reason I'm using those 2 points is because on my y-axis, I actually had 80 and 72 marked on the y-axis, so I know exactly where those 2 points are. Your graph may look different than mine because you may not have gone by eights on your y-axis, depending on how many lines you have. Maybe you went by a different number than I did. Maybe you went by sixes, for example. Sixes probably would have worked out nicely. That'd be okay. Trying to line this up the best I can. That seems okay. Go ahead and draw a line. There we go. And there's our graph. Now we could estimate this would have been about 0.82. Then 278 would have been about right there. That seems like a reasonable estimate for our 278. This would have been our 376. That seems like a reasonable spot for 376. And then 474 would have been like about right there. Those all seem like reasonable estimates for those other points, but by using points that I was absolutely sure of, I got a pretty decent line out of it. So what we did here was we took a table that was describing a situation. From the table, we were able to get the equation in slope-intercept form, and then we were able to graph it again using the coordinates that we had from the table. We could have graphed it using the equation also, but since we already had the table with those coordinates, it was just easier for us to use the coordinate that had already been provided for us in that table.